Good morning, and welcome to RCR TV's program on the LTE device ecosystem. I'm Kelly Hill, RCR Wireless reporter, and your moderator today. We're joined today by Olga Yashkova-Shapiro, Program Manager, Test and Measurement Practice, Frost & Sullivan, Venkat Nara-yanaiah, Director, Business Development, 4G Devices and Solutions for the Wireless Competency Center, Americas region of Alcatel-Lucent, and Mike Barrick, Business Development Manager for Wireless, Anritsu ASR. Anritsu was one of our program sponsors today. Anritsu Company is the United States subsidiary of Anritsu Corporation, a global provider of innovative communications test and measurement solutions for more than 110 years. Anritsu provides solutions for existing and next generation wired and wireless communication systems and operators. Anritsu products include wireless, optical, microwave RF, and digital instruments, as well as operations support systems for R&D, manufacturing, installation, and maintenance. Anritsu also provides precision microwave RF components, optical devices, and high-speed electrical devices for communication products and systems. With offices throughout the world, Anritsu sells in over 90 countries. Our program today is also sponsored by Alcatel-Lucent, a major supplier of world LTE networks. A long-trusted partner of service providers, enterprises, and governments around the world, Alcatel-Lucent is a leading innovator in the field of networking and communications technology. Alcatel-Lucent has operations in more than 130 countries. And now we move into our discussion on the LTE device ecosystem. My first question is for our analyst guest, Olga Yashkova-Shapiro of Frost & Sullivan. Olga, can you tell us about what you expect to see in 2013 for trends in LTE devices?
Absolutely. Thank you, Kelly. Mobile data consumption on smartphones and tablets is driving the demand for operators to expand their LTE networks as well as their LTE device portfolios. In addition, LTE-enabled mobile devices are expected to almost triple in 2013. We expect new entrants into LTE device markets such as Amazon, for instance, and others in 2013. As LTE networks are being rolled out globally, the demand for LTE devices is expected to come from countries such as United States, United Kingdom, Japan, and emerging areas such as Russia, Brazil, China, and South Korea. As far as the other trends are concerned, first of all, ensuring positive quality of user experience on LTE devices is extremely important for OEMs and service providers. They have to make sure that the smartphones or tablets work properly, and otherwise it will result in customer churn. Service providers are well aware that once they lose the customer, it's practically impossible to get one back. Voice over LTE is another important trend that brings significant benefits such as low cost of operation for service providers. However, if it's not implemented or tested properly, it can lead to poor user experience. Another trend is Wi-Fi in mobile devices. As Wi-Fi is becoming the key technology operators will be relying on in order to offload increasing data traffic, mobile data traffic. Wi-Fi is also known as a 5G technology, and this latest standard includes the latest technologies from 802.11n standards to provide higher throughput. 802.11ac enabled products are just entering the residential market. Soon, the products will emerge in the enterprise and carrier-grade Wi-Fi market. This will introduce a new set of test equipment to address the performance testing of .11ac products. I wanted to especially emphasize that right now, .11ac test equipment is being used in the R&D testing phase by companies. Soon, more equipment will be needed at the QA, manufacturing, and other areas of product life cycle. MIMO, or multiple input, multiple output antenna technology, is also a key trend not to ignore. Another important trend is, according to Spirent Communications, smartphone vendors are working to improve performance of indoor location capability using combination of GLONASS and GPS technology, cellular network provisioning, and Wi-Fi. Implementation of these technologies into mobile devices will continue driving the demand for LTE test equipment market as well.
Can you share some of your findings about the LTE equipment market? I'm sorry, the LTE test equipment market.
Right. Absolutely. Well, we all know that 2012 was a very important year for LTE deployment, as it symbolized that technology is becoming a mainstream technology or technology of choice for global mobile operators. From a test and measurement perspective, the emergence of LTE creates many opportunities for test equipment vendors. According to Frost & Sullivan's latest research, the global LTE test equipment market generated $945 million in revenues in 2012 and is expected to exceed a $2.8 billion mark by 2018, growing at a healthy growth rate of 20.7% from 2011 until 2018, and that's a CAGR. And I also wanted to emphasize that LTE mobile device test segment contributed the largest portion of revenue, about 53.5% to be exact, in 2012 to the overall LTE test equipment market revenue. And according to our analysis, the revenue from LTE device testing is expected to exceed $1.4 billion in 2018. I would also like to point out that most of the revenue for testing still comes from the research and development stage of the product life cycle. But with the rapidly increasing number of LTE devices, the LTE mobile device segment is expected to continue experiencing a healthy double-digit growth and offer numerous opportunities to all the players in LTE ecosystem. Just a few vendors that I wanted to point out that playing in the R&D and manufacturing stages of LTE devices, and they are Anritsu, who is present today, Aeroflex, Agilent Technologies, Anite, National Instruments, Brodie & Schwartz, Spirent Communications, and Teradyne with the acquisition of LightPoint.
Okay. Great. Mike, as one of the players in the LTE test equipment market, I'm wondering if you can talk to us a little bit about what it takes to bring an LTE device to market, and what types of testing are required to accomplish this.
Sure, thanks, Kelly. It would probably all start with the components. An OEM or original equipment manufacturer might start with components such as the baseband modem chip, the application processor chip, maybe an RFIC, power amplifier, power management IC, overall operating system, components that might not come from that OEM, or that OEM might source those components inside the company. First step would be integrating all those components together into a device. And of course, after you integrate all the components, there'd be tests at various stages, and then a design validation test at the end of the cycle. Once the device is finished, ready to come to market, then it needs to go through some type of certification test, and typically carriers would require this. Typically those are either GCF or Global Certification Forum criteria, or PTCRB, PCS Type Certification Review Board criteria. Following that, there's typically a series of tests required by each carrier that are not part of GCF or PTCRB requirements. Maybe some type of roaming that's not covered by GCF or PTCRB, maybe data throughput, other factors like that. So a series of additional tests over and above GCF and PTCRB. And the last stage, coming to market, of course, you need to get it into high-rate manufacturing. Typically, you would start with maybe a prototype manufacturing, low speed, do a lot of testing, then high-speed manufacturing, and typically there you would test with no call, very fast calibration, and parametric tests, typically in Asia these days.
Okay, great. Well, we also have joining us on audio today Venkat Nara-yanaiah from Alcatel-Lucent. Venkat, I wanted to ask you about what you think is the current LTE device ecosystem for the North American market. And kind of going along with that, what kind of LTE device form factors do you foresee as we move into the 2014 timeframe?
Okay, thanks, Kelly, and good afternoon to everyone. So with regard to the LTE device ecosystem in the North America market, as I had indicated in the previous webinar, today, with regard to the bands where LTE devices are available, LTE devices are available in band class 2, which is 1900 megahertz, band class 4, which is AWS, band class 12, which is the 700 block ABC, band 13, which is Verizon frequency. There are limited devices on the band class 14, which is public safety, band 17, AT&T frequency, and band class 25, which is Sprint. And with regard to the ecosystem itself, there are a very limited number of tier 2 vendors playing today in this market because of the high FCC certification cost. But as we go into 2013, you will see many more vendors coming into play. From the tier 1 perspective, the major tier 1 vendors who are playing the market, of course, as everyone is aware, is Apple, Samsung, LG, Moto, etc., etc. And from the tier 2 standpoint, you have RCR Wireless, you have Franklin Wireless, Bandridge, and a couple of other small vendors. As we go into 2014 timeframe, the major form factors which are going to prevail are the smartphones, tablets, and the MiFi hotspots. The USB dongle, which is currently being used, will slowly fade away. And we are seeing OEMs also trying to get USB dongles out of their roadmap and concentrate more on the smartphones, tablets, Wi-Fi, and the MiFi routers. And for fixed wireless solutions, of course, we have the indoor Wi-Fi router and the outdoor CPE.
Okay, great. Venkat, I also wanted to ask another question of you, and that's given the roaming requirements by many carriers, how many LTE bands can now be supported on a single device? You mentioned a number of bands just now, and I'm wondering if you can talk a little bit about that and what the time frame is for OEMs to enable LTE devices with multiple bands and as well as multiple fallback technologies on the same device.
Okay, so with regard to roaming requirements now, given that many small carriers are either roaming into the Sprint or into Verizon or AT&T, all these days we had constraints on the number of LTE bands which could be accommodated on a single device. Thanks to Qualcomm and their recent solution, the Alcatel-Lucent has recently enabled a MiFi pocket router with one of our tier 2 partners, Bandridge, where the MiFi router can support 6 LTE bands along with fallback to HSPA as well as CDMA on the same device. And the 6 LTE bands which it can support includes the major bands, which is band class 13, band class 17, band 25, AWS frequency, band class 2, and band class 12, which is lower 700 A, B, and C. And the time frame which we are seeing for the OEMs to enable the LTE multiple bands, today there are very limited devices with multiple LTE bands. And I mentioned we have already done that for some of the tier 3 carriers who can use that for their network. But as we go into 2013, towards the third quarter time frame, you will see many more vendors come in. Samsung today has a multi-band LTE smartphone, which has been launched with one of the tier 2 carriers as well. But in terms of the additional LTE bands, or if a carrier wants to 4 or 5 LTE bands, I'm sure by third quarter this year, you will see many more OEMs coming up with different form factors supporting these multiple bands with fallbacks both to EVD or REV-A as well as to HSPA.
Okay, great. Mike, I wanted to come back to you to ask what types of solutions Anritsu offers to help LTE device developers.
Sure. For the developer environment, we actually offer 3 solutions. Since it's a device, we offer solutions to simulate base station and network, the eNode B for LTE, plus enhanced packet core for LTE. Each of those solutions is focused on a specific area of the market. We don't just have one solution that we try to shoehorn into all the different applications. First, the 8430, or 8430 with our RTD software, focused on the device development market, more protocol focused. It has capabilities for release 8 through release 10 in carrier aggregation. It's actually the first solution to market with carrier aggregation capability. It can simulate up to 6 base stations or 6 eNode Bs, up to 4x2 MIMO, so high order MIMO, and up to 300 megabits per second data rate, category 6, with carrier aggregation. The 8475 is a second solution for LTE. It actually has 2G, 3G, and LTE capability, more focused on functional testing, like a VoLTE call performance, voice over LTE call performance, possibly SMS, MMS, those types of things. Strictly functional testing from layer 3 primarily. It is capable of release 8. Of course, 8430 is a little bit more advanced. It also has a capability to either do 2 base stations, could be 2G, 3G, LTE all mixed, or 2x2 MIMO, and it's up to category 4 type data rate, so 150 meg in the downlink. And lastly, 8820, more focused on parametric tests. At the R&D stage, you might want to do RF testing, or maybe in a factory, you might want to use it for production testing. It's similar in capabilities to 8475, 2G, 3G, as well as LTE up to release 8. You can do 2 base stations, differing types, or 2x2 MIMO, and up to category 4. So same 150 meg in the downlink.
Olga, I want to go back to you and ask you a little bit about your perspective on what the testing challenges are that MIMO brings into the LTE device ecosystem.
Absolutely. As MIMO antenna technology is responsible for about half of the data rate capacity offered by LTE, it is one of the most important drivers for the uptake of air interface test equipment. If MIMO is not implemented properly, end user experience is going to suffer. The coexistence of multiple radios in the mobile user devices presents a significant challenge. That is why the demand for successful test equipment tools is expected to continue increasing. The future of network capacity lies in the beamforming technique that uses MIMO. The challenge associated with the technology is that the technology is highly complicated, and as the number of antennas involved in MIMO increases, so does the complexity of testing. I also wanted to bring up LTE Advanced that is expected to introduce 8x8 MIMO, where 8 antennas will be required for every transmission. So this will present significant challenges for service providers and OEMs because implementing 8x8 MIMO will require significant design changes due to the interference and the ability to divide the signal.
Okay. While we're talking about LTE Advanced, I also wanted to touch on voice over LTE and the move in that direction to see that more on the voice side. What challenges does voice over LTE bring into the LTE device ecosystem?
So as we know that LTE technology brings with it a major industry shift towards a packet-based data network. So because of that, service providers will deliver voice over a packet-based network, also known as voice over LTE. The telecommunications industry is currently working on refining LTE technology throughout the entire LTE ecosystem. Testing during the research and development phase of LTE devices becomes absolutely critical for successful technology deployment, as well as ensuring positive customer experience. Voice over LTE offers a number of benefits to service providers, such as low cost of operation and additional IMS-based services such as rich communication services and visual voicemail, for instance. And however, if voice over LTE isn't implemented correctly, as I mentioned earlier, the customer experience will suffer. Another challenge that voice over LTE brings is the poor battery performance, as well as possible issues with voice quality and poor call setup time. So studies show that calls conducted on voice over LTE consume as much battery power as the calls placed over 2G CDMA networks. And this is a major concern for the industry right now. However, with proper testing, the battery performance has shown significant improvement. Latency is also something to be aware of in voice over LTE. As we know that voice quality is going to be an extremely important metric for service providers and device manufacturers, as they need to guarantee good customer experience. And another thing I wanted to emphasize is that customer experience is further compromised with voice over LTE because of poor call setup time. It takes about 4 seconds for a voice over LTE call to be set up, as opposed to just a fraction of a second. And so because of the issues I just mentioned, the voice over LTE testing should include not only development testing, but as well conformance testing and interoperability testing in order to ensure good quality of service.
Okay. Great. Venkat, I'd like to bring it back to you and talk a little bit about device availability and pricing. And especially when you were talking about smaller carriers, that tends to be a big concern. Now, given that Alcatel-Lucent is working closely on the LTE device ecosystem, how do you address this issue?
Okay. Yes, that's a major issue today. Many of the Tier 3 carriers whom we work with, one of the major concerns they have is access to the Tier 1 devices, because most of the Tier 1 vendors require larger volume commitments and larger PO commitments, which the smaller carriers are unable to commit to. So what Alcatel-Lucent has done to help the Tier 3 carriers, as I mentioned earlier, is we have established a model with the Tier 2 vendors who use Tier 1 ASIC solutions like Qualcomm, and these Tier 2 vendors are building devices for the Tier 3 carriers, and we have signed a small supply agreement whereby the Tier 3 carriers who sign up with Alcatel-Lucent or Alcatel-Lucent infrastructure have the benefit of the negotiated price between Alcatel-Lucent and the vendor, and we also make sure that this vendor is ready to accept smaller volume POs from the carrier. This way the carrier has the advantage of the pricing. They get a Tier 1 ASIC solution, and they can buy devices in smaller volumes. The model which Alcatel-Lucent has established with the Tier 3 carriers is really working well, and we hope to, today we have only data solutions like the dongle, the Wi-Fi router, outdoor CP, and the MiFi router, and we are working on the high-end solutions as well. And as we move along, if there's a need from the Tier 2 as well as the Tier 1 carriers, we can definitely work with them as well. But today, our model is being working with the Tier 3 carriers only.
Okay. Mike, I wanted to talk with you a little bit about getting LTE devices ready for sale by a carrier. Can you talk to us about what Anritsu does in that area? Mike, do you have audio?
Sorry, I apologize.
There we go. Now we got you back. Okay, I'm sorry. I had asked about what type of solutions that Anritsu offers to get an LTE device ready for sale by a carrier.
So as I highlighted previously, there's a couple of steps. First, certification test. Second, carrier acceptance test. For any of those tests that don't fall in the certification test arena. For the certification test area, we offer a couple of solutions. The 7873L RF conformance system offers most validated test cases across bands. Having a validated test case means you've gone through a certain number of steps in either GCF or PTCRB to verify that these tests work as advertised with typically 2 different wireless devices. On the protocol side, we offer the 7834L, a similar type story. Most certified or validated test cases for LTE across the protocol certification area. In terms of carrier acceptance test, we offer a number of solutions. Primarily, in most cases, it's also based on the 7834L. We typically have a number of test packages based on carrier requirements. Depending on specific carrier, it could be, as I mentioned previously, maybe handoff tests from LTE to CDMA. Could be roaming tests with multiple types of base stations. Could be other types of data throughput, that type of thing. But those would be our primary solutions for certification as well as carrier acceptance.
Okay. While I have you here, Mike, I wanted to talk a little bit about sort of the back end of the device lifecycle and have you tell us a little bit about what's important for repair of LTE devices.
Sure. Typically, a device OEM would provide a 1-year warranty when a device is sold. You know, there are all kinds of chains to sell a device these days, but I think predominantly those devices get sold through carrier stores. If a device breaks or stops working or a customer has some type of issue that can't be resolved with a call center, that device is typically returned to some large warehouse that's owned or operated by the carrier to test the device to see if it functions or does not function correctly. In that type of testing, you might have some type of cosmetic looking at the device to see if it looks like it's been dropped, it's been underwater, or anything like that. Then there'd be a test stage where you go through some RF parametric tests to see if it basically looks like it's performing per the device specification. If the device looks like it's malfunctioning, that device would be returned to the OEM that built the device for the actual repair. But there's all kinds of variations, but that would be the typical flow. And of course, repair of the device and getting it back to the customer is in the interest of the carrier, so they can have billable hours, both data as well as voice, and in the interest of the OEM, so they can have the best brand possible.
Okay, great, thanks. Venkat, coming back to you. Let's see, as TD-LTE becomes important in North America, can you comment on dual mode FD and TD-based device availability?
Sure. So TD-LTE, as you know, today is really being used in the Asia Pacific region. China is going to start using TD-LTE in band class 40, band class 38, and then Saudi Arabia is using band class 40. India is using band class 40. So as US move towards band class 41, and Qualcomm's chipset today supports TD plus FD, Alcatel-Lucent is now working with some of the vendors to enable the TD plus FD devices by the second quarter this year. So we may see devices in the second quarter, third quarter time frame in several different form factors, which will support multiple FD along with the TD bands. Of course, in the US, we are looking at band class 41, so it will probably be a band class 41 plus maybe a 25 or a 26 on the FT side. But we are looking at third quarter. By the end of this year, we'll have a few vendors who would have already enabled both the high-end phones as well as the data solutions.
And I wanted to ask us just a question about a specific vertical, and that's public safety. There is some action going on in the North American market, specifically in the U.S., in terms of the planning for the FirstNet network, which will be an LTE network. And I'm wondering what Alcatel-Lucent is doing in terms of addressing devices for public safety.
So public safety market is definitely a very interesting market. It's a little bit slow right now, but there has been a lot of movement on that last year. And Alcatel-Lucent on this space has been working with some vendors to enable band class 14 devices. So when you look at the band class 14 space, because of the lack of volume, not too many vendors have entered the space. So today, if you look at the chipset solutions, you really have 2 or 3 vendors who have those chipsets. One of them is GCT, who's got band class 14. The other one is Altair, who's got band class 14. And both these chipsets are already enabled in several of the devices which are being sold by different device vendors, including Calamp and Harris, etc., etc. Now, given that Qualcomm is also going to enable the band class 14, and generally a Qualcomm solution comes with, it's a fully loaded solution, we are likely to see some of our partners who are looking at some basic public safety-based solutions like a vehicle router by around the second quarter time frame. But again, given the lack of deployments and the lack of commitments from the public safety carriers, you are not going to see too many vendors coming into the space. So at least for 2013, there will be a few vendors, and we are already working with one vendor who will enable some of these devices by the second quarter. But when the deployments go up, you will see many more devices in this space, including smartphones, vehicle routers, dongles, and hotspots, and whatever other form factor. It's important to note that for a public safety, you need devices which are really ruggedized. So that's the key. And to build ruggedized solutions, it takes extra effort from the OEM.
Okay. Great, Olga. I want to come back to you with one last question, and that is, what do you think are the biggest device-related challenges with the transition to LTE?
I would say it is an IRAD or inter-radio access technology mobility scenario, meaning moving in and out of LTE coverage. Cellular devices must be able to move between cell and between radio technologies without causing any noticeable effect on customer experience. However, this important area of device performance is still not fully addressed by current conformance testing. And for the next few years, we all know that LTE service will be an overlay of service deployed together with existing legacy technologies. So it is very important that multi-mode devices are tested in order to ensure seamless mobility between access technologies. If it doesn't happen, it will result in higher support costs, customer churn, and lost revenues for both mobile device manufacturers as well as service providers.
Okay, great. Mike or Venkat, do either of you have any additional thoughts on what you think the biggest device-related challenges are with the transition to LTE?
So when you look at LTE, there are some of the challenges from a device standpoint. So we can categorize them as 3 separate areas. One is the device enablement. Second is the device availability. Let's talk about device enablement. Now, some of the challenges which we are noticing with regard to device enablement is, as Olga mentioned, the IRAD technologies. When LTE has to roam between HSPA and CDMA, the testing aspects are extremely important, and that's the reason when we go through the testing process is generally quite long, because we need to make sure the device is actually moving smoothly from LTE to CDMA and vice versa. Now, when it comes to device availability, as I mentioned earlier, many of the Tier 3 carriers, one of the biggest challenges they have today is the device availability, which is slowly being addressed first by Tier 2 vendors and then maybe by Tier 1 vendors. Last but not least is everyone wants to move towards VoLTE. VoLTE is likely to be available third quarter in 2013 from some Tier 1 vendors. But the question is, when you move towards VoLTE, there are some limitations, the battery life of the device and the voice quality, etc., etc. So VoLTE is one of the biggest challenges, and in my opinion, if the carrier is going to offer VoLTE, they probably will have to even charge additional money to the subscribers, which is another big challenge for the carrier. So these are some of the challenges which we see today with regard to device enablement from the LTE perspective in different categories.
Okay. Mike, did you want to add anything from Anritsu's perspective on what you think the biggest challenges for devices with the transition to LTE?
No, I think Olga and Venkat have covered it fairly well. Interrat is one of the biggest issues, and it's Interrat to WCDMA, GSM, C2K, and even for the Chinese market, TD-LTE. Of course, MIMO is an issue. Currently, we're at 2x2. It could go to 8x8, I think, as Olga has mentioned previously, although 8x8 is in the far horizon as far as we can see. Carrier aggregation is coming online this year. That will be a technical challenge. But I think those three things, primary challenges in terms of technology for LTE.
Okay. Great. Well, thank you, everyone, for joining us today. This has been our RCR TV program on the LTE device ecosystem. Thank you to Olga Yashkova-Shapiro from Frost & Sullivan, Mike Barrick from Anritsu, and Venkat Nara-yanaiah from Alcatel-Lucent. Thank you so much.
Thank you, Kelly.